So as you can see here, our quadratic equation, right? We have in function notation f of x is equal to ax squared plus bx plus c, right? And a cannot equal 0, otherwise it wouldn't be a quadratic. So the shape of this graph is called a parabola. A parabola is kind of a U-shaped graph. And as you can see over here in the bottom left, you have a parabola that opens upwards. This is, let me write this in, this is a parabola, opens upwards. And on the right here, this one opens downwards. So I'll be using that phrase, these phrases, often throughout this section, okay? So how do we know whether the parabola opens upward or downward? You can tell by the A. So if you see that the A is greater than 0, then it opens upwards, right? If it's less than 0, so meaning if it's a negative number, it's downward, okay? And at the lowest point right here, when it opens upward, we have this lowest point. Well, either way, it's called a vertex, but when it's lowest point like this, it's also called a minimum. So remember, when it opens upwards, it has a minimum. If it opens downwards, we have a maximum, right? And you can see why they're min and maxes, right? Min meaning the minimum or the lowest, max being the highest, okay? Now, a parabola, another cool thing about a parabola is there's a line, an imaginary, not a, yeah, imaginary line going down this, not imaginary, but there's a line going down there. This is called the axis of symmetry. Let me use a thinner color, or thinner pencil here. Axis of symmetry. What does that mean? That means this is a line that you can see the parabola is symmetric on both sides, right? So on the left-hand side, what does that mean? That means if I, from this line, if I go three units to the left, right? That means the y coordinate is exactly the same as if you went 3 units to the right of this axis of symmetry. Okay, so basically you can, if this were on a piece of paper and you folded along that axis of symmetry, right, and you kind of look through, if it was like a tracing paper, you'd be able to see that the graph lines up perfectly. Okay, let's move on to the next page. Oh yeah, here's exactly what I was talking about, right? So from the axis of symmetry, right, you can see the pink line here is the axis of symmetry. So these points right here are called symmetric points, meaning if you go 5 units to the left and 5 units to the right, you get the same exact y value, right? Okay, and then since this is opening upward, we have a vertex, which is our minimum. Okay, and make sure when you graph these, you graph it with a curve. These are not straight lines that we're drawing here. Okay, let's see here. Let's do our first, well, this is not our first example here, but this is kind of explaining how if we were to use the equation ax squared, y equals ax squared plus bx plus c, right? When x is equal to 0, that gives us the y-intercept. Okay? Remember how when we were drawing graphing lines, right? Linear equations, two variable linear equations, y equals mx plus b. When we substitute x is equal to 0, you do recall that gives us the y-intercept, right? So same thing here. When you substitute a 0, let me use a different color here. So if you plug in x is 0, what happens? You get y is equal to a times 0 squared plus b times 0 plus c. So anything times 0 is 0, right? So that leaves us with y is equal to just c. This is the y-intercept. So that's what this graph here is explaining. And the vertex, the way we get the vertex, right, is by doing this formula here. X is equal to negative b over 2a. So if we take our ABC, remember this has to first be set equal to 0, which it should be. It's going to be given to you in either y equals or a function notation. So all we have to do is take our AB, do negative b over 2a, and that gives us the x coordinate, right? This is the x coordinate of the vertex. And we take that number and we substitute it in for x to get the y coordinate. So we'll be doing these a little bit later. Let's move on for now. This is just when they put it in factor form, figure out the numbers. Okay, so actually we're going to take a look at, remember also the vertex, I forgot to mention, the vertex is on the axis of symmetry, right? So that equation, negative b over 2a, actually is the line, the equation of the line for the axis of symmetry. Okay, let's see here. We have f of x is equal to x squared plus 2x minus 8. Let me zoom in just a bit. Okay, so let's find the axis of symmetry in this equation and then the vertex. So we take our a is equal to 1 and our b is equal to 2, right? Right here, this is 1 and this is our 2. So we do x is equal to negative b over 2a. So that gives us x is equal to negative 2 over 2 times 1. So that is negative 2 over 2 equals negative 1. So this axis of symmetry, I'll just write sim for short, is the x is equal to negative 1. And if you recall from chapter 3, we learned how to graph equations, right? Lines like x is equal to 1, negative 1, right? So if you can see here, right here, if you have your y-axis, your x-axis, right? It's a vertical line, 1 unit to the left. So there's our axis of symmetry. All right, next we have to figure out what the vertex is. So what we do, we have to take the function that they gave us and plug in negative 1 for x. So I'm going to do f of negative 1 here is equal to, so the function was x squared plus 2x. Let me write the function here so you could see it. X squared plus 2x minus 8. So I'm going to substitute negative 1. So negative 1 squared plus 2 times negative 1 minus 8. So this is positive 1 minus 2 minus 8 gives us negative 9. So the vertex, the coordinates are negative 1, negative 9. So as you can see here, right, they plugged in the vertex right there in the bottom, right? This is our vertex. And the pink line is axis of symmetry. Okay, now to plot more points, I do recommend, if possible, to get the y-intercept. Oh, did not mean to do that. So how do we find the y-intercept? we have to substitute 0, right, for x. So let's substitute 0. F of 0 is equal to 0 squared plus 2 times 0 minus 8. So that gives us negative 8. So our y-intercept is 0, negative 8. And you can see 0, negative 8 is this point right there. Right? So is everyone okay with the points that we just figured out, the vertex and the y-intercept? Does anyone have questions up to this point? Yes, no? Okay, if not, I'm going to move on, okay? Now the function we said was f of x is equal to, let me zoom in just a bit, x squared plus 2x minus 8. So this is a quadratic equation. We need to solve the quadratic equation. We've been doing it for almost the entire chapter. That means this is set equal to 0, and we solve for x. What are the 3 ways that we learned how to solve a quadratic equation? So the first way was solve quadratic equation, right? We did it by factoring. The second way was completing the square. And the most recent way was quadratic formula, right? We just did the homework for that. Now, I said if possible, whenever possible, quadratic is the quickest way. So this looks like you can not the quadratic, I'm sorry. Factoring is the quickest way. So this looks like it's factorable. I'm going to factor it. I'm going to do x plus 4, x minus 2 is equal to 0, right? Those are the factors. So you set each factor equal to 0 using our zero factor property or rule, and solve for x. So x is equal to negative 4, or x is equal to positive 2, right? This was from early in this chapter 8. Okay, so what does that mean? That means these are our x-intercepts. This is when y is equal to 0, right? Earlier we said y-intercept is when x is equal to 0, and the x-intercepts are when y is equal to 0. So as you can see, the coordinates for this would be negative 4 for x, 0 for y, 2 for x, 0 for y. Does that make sense? So going up to this graph, I'm going to plot these 2 points. So 2, 0 right there, and negative 4, 0. And where did this negative 1, 9 come from? Well, what did we say about this axis of symmetry? Right? It makes it symmetric on both sides. So this 0, 9, right? I'm sorry, 0, negative 9. I'm sorry, not 0, negative 9. 0, negative 8, right? Was our y-intercept, right? This was our y-intercept. So you notice it's only 1 unit away from the axis of symmetry, right? So that means 1 unit to the left is going to have the same y value, which is negative 1, negative 9. I'm sorry, not negative 1, negative 9. Negative 2, negative 8. So this is negative 2, negative 8. This one is 0, negative 8. Okay, is everyone clear on those, how I got negative 2, negative 8? All right, well, now that you have these points, you can sketch the curve and have a parabola that opens upward, right? Now, why does it open upward? Oh, wow, this moved. Does anyone know why this parabola opens upward? Well, a is greater than 0. Very good. It's positive. Oh, no. What happened to it? Oh, there it is. Very good. A is greater than 0. Therefore, it opens upwards, right? That was the rule. If a were less than 0, if it were a negative number, we would have to open downward. Okay, so that's how you can double check whether you did all your math correctly when you're graphing. Okay, so let's move on to check yourself 1 and try to figure out all the things that we just did here. So let me write down what we need to have here. So we need to have the axis, oh, that's not it. Oh, why did it do that? Okay. Okay, let's go back here. Pen is black. Okay. So the first thing we need is the axis of symmetry. Right? And the second is vertex. The third is my y-intercept. Right? And you can also do the point symmetric or the symmetric point. Let's write it that way. Symmetric point. And lastly, the x-intercepts. Oh gosh. X-intercepts. Okay, so remember axis of symmetry is when you do x is equal to negative b over 2a. Right? And the vertex is when you substitute x is in, we gotta substitute negative b over 2a into the function and get the y, right? So please try that. Let's see if I can, I guess that's the one thing I can't do is, okay. So let's get the axis of symmetry. So I've identified a as negative 1, b as negative 2, and c as 3, right? So I have to do x is equal to negative 2 over 2 times negative 1. So that's positive 2 over negative 2 is equal to negative 1. Did everyone get that? That's the axis of symmetry. All right, now we take this negative 1, we substitute it into the function, right? Oh, let me write axis of symmetry here. Okay, now we do f of negative 1, which means minus negative 1 squared minus 2 times negative 1 plus 3. So this part here still is negative 1 plus 2 plus 3. So this gives us 4. So the vertex is what? Negative 1, 4. Did everyone get the vertex? Okay. What's the y-intercept? Well, the y-intercept is when you substitute 0 for x, right? So that's f of 0 is equal to minus 0 squared minus 2 times 0 plus 3, right? So you can see this is just 3. So the y-intercept is 0, 3. Lastly, well, the point symmetric will work on that with the graph. But number 5, the x-intercepts, right? We have to factor if possible. And we have to, well, first I'm going to write it as equal to 0, right? Negative x squared minus 2x plus 3 is equal to 0. So I see that the leading coefficient is negative, right? If you recall the problems where we have a leading coefficient of negative, we factor that out. So we get x squared plus 2x minus 3 equals 0, right? And then we can divide both sides by -1. That way, the negative cancels out, and we have x squared plus 2x minus 3 is still equal to 0. Now we factor, right? Okay, so when we factor, we get x plus 3 times x minus 1 is equal to 0. If we set each factor equal to 0 and solve for x, we get two solutions. X is equal to -3 or x is equal to +1. Okay, let me move down here. Oh, actually, let me move to the right because we have graph paper here. Oh, okay, now I can see it. Okay, did everyone get those x-intercepts and the y-intercept? Okay, so how come we can't even see the graph paper? Oh, there you go. Oh, it disappears. Okay, well, I'll just make my own lines then. It's okay. All right, so I'm going to plot the axis of symmetry. Let me just circle the things that we're going to be using. We have over here, okay, x is equal to -1, vertex is -1, 4, y-intercept 0, 3, and then the x-intercepts are -3, 0, and 1, 0. Right, that's what we have. So I'm going to draw a vertical line like that, and then I have, there you go. So I have 1, 0 there, -1, -2, -3, 0, and 1, 2, 3, 4. Okay, let's plot some points. So I have my axis of symmetry. I'll draw with this thin green line. It's at where? -1. So I have this vertical dotted line, which is the axis of symmetry, like that. And I'll just label it x is equal to -1. Well, I should label the y-axis and the x-axis too. Okay, now with my other, okay, let me plot the vertex, -1, 4. -1, 4 is right there. 0, 3 is right there. And the point symmetric is 1 unit away from the axis of symmetry, right? 1 unit to the left would be the point symmetric. Okay, so I'm going to just label this. This is the vertex, -1, 4. Y-intercept is 0, 3. So the point symmetric is 1 unit to the left of the axis of symmetry, so that's -2 with the same y, 3. And then the x-intercepts are -3, 0, and 1, 0. And you can see, right, if you draw your curve, this continues down, and the parabola opens downward, right? So draw your arrow symbols there, right? And the parabola, should it be opening downwards? You should be asking yourself that as you do these types of problems, right? You have your A is what? A in this case was -1, right? That's less than 0, meaning opens downward. Okay? How many of you got this correct? So I think the only way to really get this and be comfortable is to practice a lot. Alright, so let's try another one. We'll do one more together, and then you'll have to do your own. Okay, let's see here. We have f of x is equal to x squared minus 6x plus 3. Okay, so I know a is 1, b is negative 6, c is 3. So we can get the axis of symmetry first, right? So the axis of symmetry is x is equal to negative b over 2a. So b, negative b over 2a. So that's positive 6 over 2 equals 3. Alright, so the vertex is when you substitute that 3 into the function. So f of 3 is equal to 3 squared minus 6 times 3 plus 3. So that's 9 minus 18 plus 3. So that's equal to negative 6. That means the vertex is what? X is 3, y is negative 6. Next is our y-intercept, right? Y-intercept is when you substitute 0. So f of 0 is 0 squared minus 6 times 0 plus 3. So that gives us just 3. Y-intercept is x is 0, y is 3. Right? See, once you get the hang of it, you see how quickly this flows, right? Now the x-intercepts, if they exist, right, with the factor. So x squared minus 6x plus 3, you set that equal to 0 and see if it's factorable. Now I can tell this is not factorable. So how do you solve a quadratic equation that is not factorable? Right? The second method should be what? The quadratic formula we just did, right? So again, we know a is equal to 1, b is equal to negative 6, c is equal to 3. So I'm going to do x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so that gives us positive 6 plus or minus, this is 36 minus 12 over 2. Right? So you can see this is going to come out to 24 here, right? So this is 6 plus or minus radical 24 over 2. 24 is 4 times 2, right? So radical 24, root 4, root 6, not 2, right? So it's 2 root 6. 6 plus or minus 2 root 6 over 2. And I can see there's a common factor of a 2, right? So let's factor that out. We get 3 plus radical 6 over 2. And now the 2's cancel out. So we have x is equal to 3 plus or minus, I forgot the minus there, radical 6. Two solutions. Now when we're graphing, right, radical 6 is hard to graph. So what I would do is get a decimal approximation of 3 plus the radical 6 and the 3 minus radical 6. But even if we don't graph it, it's okay. Okay? Because what can we do? We can graph the other points. We only need 3 points total to really sketch this anyway. Alright, so the axis of symmetry, we said is x is equal to 3. So as you can see, this vertical line here is the axis of symmetry. X is equal to 3. Our next point is our vertex. We said is 3, negative 6. So as you can see, 3, negative 6 is down there in green. It's labeled, right? The y-intercept is 0, 3. So they plot 0, 3 right there. And then the x-intercepts, the points over here, they're not labeled because it's hard to label that. But anyway, what is 3 plus radical 6? On the calculator, it comes out to approximately, here, let me do it over here. 3 plus radical 6 is approximately equal to 5.45, right? And 3 minus radical 6 is approximately equal to 0.55. So as you can see, the graph crosses the x-axis around 0.55 there and 5.45 over there on the right side. Okay? The point symmetric in this case will be the point symmetric to the y-intercept, right? So how many units away from the axis of symmetry is the 0, 3? It is 1, 2, 3 units away, right? So I'm going to count 3 units to the right, and I'll get 6, 3 as the point symmetric, or the symmetric point. You can call it either. Okay, so this is the y-intercept, and this was the vertex. Okay, so is everyone getting a better understanding of how to get all the parts of the parabola and graph it? Alright, well, let's try this. Yeah, it's just going to take practice, really. Alright, let's graph the function f of x is equal to x squared plus 4x plus 5. I'll give you some time to do that. We have a is equal to 1, b is equal to 4. So for the axis of symmetry, that's x is equal to negative b over 2a. So that's negative 4 over 2 is equal to negative 2. Everyone got that? So that's my axis of symmetry. Okay, next we have to find the vertex. So to find a vertex, you take x is negative 2 and substitute into the function. Right, so you get negative 2 squared plus 4 times negative 2 plus 5. So that's positive 4 minus 8 plus 5 is equal to 1. So the vertex comes out to negative 2, 1. Did everyone get that? Alright, now that we have the vertex, we can find the y-intercept, right? So y-intercept is when we substitute f of 0. So 0 squared plus 4 times 0 plus 5 is equal to 5. So the y-intercept is x is 0, y is 5. Everyone got that, I hope, right? Next is our x-intercepts. So what I do is I set it equal to 0, the function equal to 0. And I factor if possible, right? This one does not look factorable. So I have to, let me write the c here. C is 5, right? So we have to do the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac, right, over 2a. Alright, so let me see something real quick here. This is 16 minus 20. Negative 4 plus or minus the square root of 16 minus 20 over 2. So this comes out to negative 4 plus or minus the square root of negative 4 over 2. So negative 4, right? Square root of negative 4 becomes 2i, right? So negative 4 plus or minus 2i over 2. And I see that 2 can cancel out, right? 2 can factor out. So 2 times negative 2 plus or minus I over 2. So the 2's cancel out. So we have negative 2 plus or minus I. Okay, so this is a complex number. If you recall, we can't graph complex numbers, right, on the real number line. So that means there are no x-intercepts, right? This tells us there are no x-intercepts. Okay, so let's continue with our sketch. Why is this not moving? Oh no. Okay, anyway, I'll sketch on the graph on the left here. Oh, there you go. Alright, let's sketch here on the left. Why is it so slow? It's not responding. Okay, there we go. Goodness. Alright, so we have the axis of symmetry is -2. So -1, -2. And the vertex is -2, 1. And we have the y-intercept 0, 5, 2, 3, 4, 5. Okay, so I'm going to draw 2 to the left because we said the axis of symmetry is equal to x equals -2, right? So -2, we draw that straight line there. Y and x-axis. Axis of symmetry, x equals -2. The vertex is -2, 1. So that's this point right there. The y-intercept is 0, 5. Right? So the point symmetric to this 0, 5 would be 2 units to the left and up 5, right? So y-intercept was 0, 5. The vertex is -2, 1. The symmetric point is -4, 5. So now that we have 3 points, right, one on each side, we can sketch the curve of the parabola like this. It should be going up like that. Okay, why is there no x-intercept? You see, even on the graph, it doesn't cross the x-axis. Therefore, there's no x-intercept. So that was a little curveball for you.